Hi, this is Dr. Kraus with a quick demo on how to use my random root locus practice problem generator. My students can download this code off of Blackboard. If you are not actually enrolled in my class and are just watching this on the internet, I will make a link to the code on GitHub. Note that downloading an IPython file from GitHub might seem a little weird. GitHub displays them really nicely. But if you want to download them, you got to look at it in raw format, and that's going to, I think, and that is going to, I mean, obviously you could just pull the code using standard Git tools, and that would be maybe the easiest way. But otherwise, if you click on the raw version, you're going to look at plain text. An IPython notebook ultimately has text behind it, and so you could copy that text and paste it into an editor, or you could do a file save as and save it as a .ipynb. You'll end up in a weird battle in that your browser will probably want to add a .txt to the extension to protect you from scary internet code. At any rate, let's talk through this. So I'm importing some kind of normal stuff. I've tried to do this in an intelligent way so that it's generating what I would consider to be good and reasonable root locus practice problems and not just totally random ones. So there are some kind of rules that it has to follow. It's only allowed to have at most one unstable pole. It can't have pure integrators and pure differentiators because they would cancel each other out. I only allow one complex conjugate pair of poles. I don't do any complex zeros, those kind of things. So those are tied up in some of the rules in these different functions, and you can try to understand those if you really wanted to. The main way that I intend for this code to be used is that you would execute through those things, and you get down to here, and you would generate a random transfer function, and you would look at that transfer function, and you would first decide, okay, I'm going to try to sketch that root locus without generating the answer, and then after you have your own sketch, you would then execute the next line down and compare your sketch to this thing, and that's a pretty cool looking root locus, if I must say so myself, although it was random, so I can't really take too much credit for it. And then if I wanted to generate another problem, I would just come up here and say, okay, show me another random transfer function. Okay, I'm going to sketch that one out. I see one real pole. I got one real zero. I got 4 poles. I don't know. Let's see what that looks like. Okay, yep, that makes sense to me. Those kind of things. You may not want to do this, but the other thing, so you can just keep doing that all day long. Okay, I'm going to sketch that one. I got 1 real zero. I got 2 poles. And you may have to, okay, that's a good example of, you may also end up having to play around with the X limits on these, because that looks like it zoomed way, way out. I thought about doing like the most you're allowed to do is a factor of 2 times whatever the highest magnitude polar zero is or something. I didn't do it. Okay, yep, that makes sense to me. You could also, if you wanted to, this would make more sense to me in a Bodhi world, but you could generate the transfer function without looking at it, generate its root locus first, and then ironically I get another one that has an xlim problem. And then you could ask yourself some kind of conceptual problems or try to do something from there if you wanted to. So you don't have to show yourself the transfer function. Probably makes the, like I said, I'll show in my Bodhi one later that I think there's a good case for, I'm going to generate the Bodhi plot without looking at the transfer function, try to infer the transfer function from the Bodhi plot, and then look at the transfer function. I think that's slightly less intuitive from the root locus standpoint, but it can be done. And you can just keep re-executing these last 2 chunks over and over again. And just see what you can learn, and practice as many practice problems as you want. Thanks.